In this video, we're going to use the following integration rules to get the antiderivative of a given function. So for this case, the antiderivative is x plus c. This is for the constant multiple. This is the power rule for integration, wherein if we have x raised to n, the antiderivative is x raised to n plus 1 over n plus 1 plus c, where n should not be equal to -1. And for cases that n is equal to -1 or x is raised to -1, the antiderivative is ln of the absolute value of x plus c. And this is for the sum and difference rule. And the antiderivative of e raised to x is equal to e raised to x plus c. So let us try to answer some examples. So let's say we have the integral of 3 dx. So we can have this as 3 and then integral of dx. Going back to our earlier slide, we have the integral of dx is equal to x plus c. So therefore, this would be 3, and then this would be x plus c. So simplifying, this would just be 3x, and then if I do 3 times c, that would still be a constant. So that would be 3x plus c. So this is our antiderivative. Another example, let's say the given is the integral of x cubed plus x squared minus x. So we can have this using the addition property. That would be integral of x cubed plus the integral of x squared minus the integral of x and then dx. So applying the power rule for integration, we can have x raised to 3 plus 1 over 3 plus 1 plus x squared plus 1 over 2 plus 1 minus, we have the exponent 1 here. So this would be x raised to 1 plus 1 over 1 plus 1. So simplifying, we have x raised to 4 over 4 plus x cubed over 3 minus x squared over 2 plus c. So this is the antiderivative of the given function. We can do checking by getting the derivative of our answer. So this can be written as 1/4 x raised to 4 plus 1/3 x cubed minus 1/2 x squared and then plus c. So getting the derivative of this function, we can have 1/4, and then the derivative of x raised to 4 is 4x cubed plus 1/3. The derivative of x cubed is 3x squared minus 1/2. Derivative of x squared is 2x, and then the derivative of a constant is 0. We can simplify this one. 4 over 4, and we have 3 over 3, and also 2 over 2. So what's left would be x cubed plus x squared minus x. So that is our given here. Another example, let's say we have to get the integral of 2x squared plus 3x minus 1. So we can have this by constant multiple rule. This would be 2, and then integral of x squared dx plus 3, integral of x dx minus integral of dx. So doing this, you have 2, and then power rule, integration, x squared plus 1 over 2 plus 1 plus 3 multiplied by x raised to 1 plus 1 over 1 plus 1 minus integral of dx is x and then plus c. Simplifying, we can have 2, and then we have x cubed over 3 plus 3 And then we have x squared over 2 minus x plus c. We can also have this as 2x cubed over 3 plus 3x squared over 2 minus x plus c. You can also do checking by getting the derivative of this answer, and then you will have to get the given here. Another example, this can be written as the integral of, let's say, 3x squared plus the cube root of x is x raised to 1/3. So we can have this as 3, and then the integral of x squared, 3x, plus the integral of x raised to 1/3, and then dx. So by power rule for integration, we have 3, and then this would be x squared plus 1 over 2 plus 1, plus we have x raised to 1/3 plus 1 over 1/3 plus 1 plus c. So simplifying, this would be 3, and then x cubed over 3 plus x raised to 1/3 plus 1. We can have this as 3 over 3. Same thing here. So we have x raised to 1 plus 3. That would be 4 over 3 over 4 over 3, and then plus c. So 3 over 3, that would be 1. So what's left is x cubed. And then simplifying, x raised to 4/3 over 4/3. Okay, you have to get the reciprocal of this. So therefore, we have 3 over 4. And then this will be x raised to 4/3 plus c. If you need to express this in radical form, for our second term, that would be x cubed plus 3. And then we have x cube root of x over 4 plus c. So this is our antiderivative. Another example, we can write this as the integral of x squared over x plus x over x plus 1 over x dx. So we have divided all the terms of our numerator by x. So simplifying, this would be x squared over x is x. X over x would be 1 plus 1 over x and then dx. Applying the rules, we have the integral of x dx plus, and then integral of, that would be 1. So let's just write dx plus the integral of 1 over x dx. So integral of x would be x raised to 1 plus 1 over 1 plus 1 plus integral of dx would be x and then plus c. Later we'll add c plus integral of 1 over x is ln of the absolute value of x plus c. So remember that for functions wherein the exponent is -1, the integral is ln of the absolute value of x plus c. This is the same. 1 over x is the same as x raised to -1. So to simplify, so for our final answer, this should be x squared over 2 plus x plus ln of the absolute value of x plus c. So this is our antiderivative. For another example, we can have this as 7 and then integral of e raised to x then dx. So we have this as 7, and then based from our earlier rules presented, the integral of e raised to x is e raised to x, and then we add c. So this is our antiderivative for the given function.